Hello everybody, my name is Mohit Deshpande, and in this video I want to show you guys how we can apply convolution using OpenCV and NumPy. So I've already imported both of those and loaded up my image, and so now we can actually apply convolution, and just like a lot of things with OpenCV, it's a single line of code to apply convolution. We don't have to do that calculation or anything. NumPy automatically does all this. NumPy and OpenCV automatically will do all this for us. We just have to supply an image and a kernel. So let's start simple. Let's use what's called the identity kernel. And it's called the identity kernel because when we convolve it with an image, we get that same image back. So I'm going to declare a capital K equals np.array, and the identity kernel looks like this. The first is the 3 byte identity kernel, I should say. 0, 0, 0. Top rows are row zeros. Then 0, 1, 0. And then 0, 0, 0. And if you remember, you can kind of see why this is the identity kernel, because everything else, if this is the anchor point, then everything around the pixel does nothing to it except for the pixel at the anchor point itself. So let's kind of think of expectations wise. We fully expect this to return an image that's exactly the same as our original image. So let's go ahead and compute the convolution. So doing this is really simple. We can just first create a variable convolved, and then that equals, and the CV function that we're going to be using is called filter2d. And the first thing that it takes is the image. The second thing that it takes is what's called the depth, and that just really quickly, that just basically corresponds to how many color channels or lack of color channel that the image has. For example, if we're using RGB, then the depth is going to be 3 because we have an RG and a B. Using grayscale, the depth is just 1. If you're using something like CMYK, then the depth is going to be 4. But we don't have to know any of this ourselves. In fact, it turns out if we just put in -1, that's kind of a special flag to OpenCV that'll tell us to just compute this convolution for the entire depth of this input image. So we don't actually have to figure that out. We can just let OpenCV figure it out. And so then the last thing that we need is the actual kernel that we're going to be convolving with. That's capital K. And this is all that we need. So let's actually show the image. And in fact, let's show the original image and this convolved image. So let us actually do cv2.imshow the original, and it's going to show image. And we'll have cv2.imshow convolved, and that's going to be involved here. And then we'll have to do the cv2 wait key 0 and cv2 dot destroy all windows, and let's go ahead and run this. And we can see that with convolved and with the original, they're indistinguishable, and that's exactly the case that we expect, right? Because this is the identity, we expected the convolved version to look exactly like the original, and it turns out it does. So okay, that's good and all, but let's do something that's a bit more complicated than just this. So I say, okay, let's do something more. Let's complicate this kernel a bit by, let's say we use a sharpening kernel, for example. So sharpening kernel is going to look something like this. So -1, 5. We have the highest weight of the sharpening kernel is at the anchor point, and then there's -1 weights, kind of top, bottom, left, right, and here we go. And actually what I'm going to do is I will actually just kind of space this out a little bit so that we can kind of see that it still kind of resembles a matrix there. Okay, so now let's actually run this, and what we expect is for the convolved image to be much sharper than the original image. And so let's actually run this and see what happens. Okay, so here is my convolved image, and here is the original, and you can tell that these two images are not the same at all. And in fact, some of the blurry portions of this image have actually been, crisped up into edges here. So that's kind of what the sharpening kernel does, and it applies, it's this nice effect that you get on an image. So anyway, this is just to kind of demonstrate that this works for not just, as a particular kernel, but for any kernel. So let's go back to our code here, and that's kind of all that I wanted to discuss in this video, because convolution with OpenCV is super awesome because it's one line of code, line 12 right here. It's called filter2d, pass it in an image. Second parameter, we almost always pass in -1 so that OpenCV will just automatically figure out the depth. And then we pass in the kernel. And then you see that I actually didn't, the only code I changed was the kernel. And when I changed the kernel, we produced a drastically different result. So that's all there is to it with convolution using OpenCV. So just to recap what we did in this video, I showed you how we can involve an image with a kernel in OpenCV using filter2d, and we were able to see the output of that, and we noted that the convolved image, if we're using the sharpening kernel, is going to look drastically different, except we also showed how the identity kernel actually produces an image that's exactly like the original. So that's kind of what covered in this video. We covered how we can do convolution with OpenCV.